Before talking about the enantiomers, let's go over the concept of mirror images, and particularly when it pertains to organic molecules. Any object has a mirror image. No tricks or magic here. Just put a mirror in front of anything and you'll see its mirror image. Take, for example, the mirror image of an apple, a table, or a glass. For these objects, the mirror image is same as the object. If the object and its mirror image are the same, they are superimposable. Take an example of this flask. Its mirror image is same and the two can be superimposed on each other. Such objects where mirror images are same and can be superimposed are called achiral objects. The same goes for molecules. Achiral molecules are superimposable to their mirror images, which indicate that the mirror image is the same compound. Consider, for example, the ball and stick model of a molecule represented as C. Its mirror image will look like this. Let us call it D. If we try to overlap molecule D on C, it appears that these are not 100% superimposable. However, if we tip C on its side like this, it will look like this. If we now try to overlap this new C on the mirror image D, it overlaps absolutely on D. Each group on C overlaps on its equivalent group in D. To understand it further in terms of a real molecule, take 2-propanol as an example. It is represented as C. The mirror image shown is called D. You can see, if we attempt to superimpose D on C, it appears they are not superimposable. However, just like we did in case of previous ball and stick model, if we tip molecule C like this, we get a new representation of C. If we now try to overlap this C on the mirror image D, we see all atoms or groups in C overlap on their corresponding atoms or groups in D. Hence, the 2-propanol and its mirror image are said to be superimposable. The other way of saying this is that C and D are same molecules. And like we said that superimposable items are achiral, same goes here in case of molecules, that superimposable molecules are achiral. We will discuss the reason why 2-propanol and its mirror image are superimposable, but before that, let us see, what if an object and its mirror image are non-superimposable despite the tipping or rotations we attempt to make them align for superposition? If the object and its mirror image are not the same, then they are non-superimposable images. And any object that is non-superimposable on its mirror image is said to be chiral. For example, let's look at the glasses shown here. One of the lenses is replaced with a dark lens, so that the mirror image is now different. You cannot replace the glasses with the mirror image. It does not repeat the object in space, because the position of the lenses is different. Likewise, if we put a mirror in front of the left hand, what we see in the mirror is the image that looks as right hand. And if we try to overlap the two, we see that the two cannot superimpose on each other. Such objects are therefore called chiral. Most screws have right-hand threads and are turned clockwise to tighten. The mirror image of a right-handed screw is a left-handed screw, turned counterclockwise to tighten. Thus, screws are non-superimposable on mirror images and therefore chiral object. Likewise, those of us who are left-handed realize that scissors are chiral. Most scissors are right-handed. If you use them in your left hand, they cut poorly, if at all right-handed person can use them in left hand. A left-handed person must go to a well-stocked store to find a pair of left-handed scissors, which is the mirror image of the standard right-handed scissors. The same goes for molecules. Like chiral objects, chiral molecules are not superimposable on their mirror images. In other words, molecules that are not superimposable on their mirror images are chiral. Consider, for example, the ball and stick model of a carbon-centered molecule. Each color depicts a different atom or group attached to the carbon center. The mirror image will look like this. If we try to overlap the mirror image on the original molecule, we can see that the two mirror images are not 100% superimposable on each other. And this is true if we rotate such a molecule by any angle. Without any rotation, 3 out of 4 groups, and with rotation, 2 out of 4 groups, will not overlap on the corresponding groups in the mirror image. Thus, for molecules to be categorized as non-superimposable, there should be no orientation in which mirror images can be 100% superimposed on each other. To understand this, let us take this molecule A, in which carbon is joined to 4 different groups depicted by different colors. Its mirror image is like this, denoted as B. We have seen that 2 can't be superimposed. Let us flip A over so that this red group points towards left. After flipping, we get this representation. This is still molecule A, as we have rotated the molecule. If we now try to overlap it on B, we see that black and red group overlaps on their respective counterparts in B, but the other 2 groups don't superimpose at all. Thus, whatever rotation we execute, molecule A will not superimpose on molecule B. Thus molecule A, and its mirror image B, are different molecules. Let us apply this to a real molecule 2-propanol named as A. The carbon 2 is attached with methyl, ethyl, hydroxyl, and hydrogen. For clarity, 4 different groups are shown with different colors. For easy understanding, ball and stick model of this molecule is shown here. If we put a mirror in front of this molecule A, the mirror image will look like this molecule. Let us name it as molecule B. The corresponding ball and stick model is shown on the right. If we try to superimpose the mirror image B on original molecule A, we can see these cannot be superimposed. As we have done earlier, if we flip the molecule A so that hydroxyl group moves towards the left side, as in B, we get this new representation of molecule A. Remember, it is same as original molecule A, as we have only rotated the molecule. If we now try to superimpose this flipped A on mirror image B, we see black and red groups overlap but not the other 2 groups. Thus, molecules A and B cannot be superimposed. Such molecules which cannot be superimposed on their mirror images, no matter how you rotate them, are said to be chiral. These non-superimposable mirror images are called enantiomers. Thus, A and B are non-superimposable mirror images of 2-propanol and are enantiomers. Therefore, we must remember that if 2 molecules are non-superimposable mirror images, they are called enantiomers. And any molecule that has an enantiomer is chiral. Or, if a molecule is chiral, it must have an enantiomer. For example, this derivative of methane molecule, which has 4 different groups attached to carbon center, called as bromochlorofluoromethane, cannot be superimposed on the mirror image and is therefore chiral. This means the 2 images are enantiomers. Next, we need to discuss what makes a molecule chiral, or what makes mirror images of molecules to be non-superimposable with the original structure. Although there are different types of chiralities, Most often the origin of chirality in organic molecules is the presence of an asymmetric center. An asymmetric center is any atom, with 4 different groups or atoms attached, and this is the most common example of a chiral or chirality center. Chiral center is any atom, holding a set of ligands in a spatial arrangement, that is not superimposable on its mirror image. Chirality centers belong to an even broader group, called stereocenters. A stereocenter, or stereogenic atom, is any atom, at which the interchange of 2 groups gives a stereoisomer. Asymmetric centers and the double-bonded carbon atoms in cis-trans isomers are the most common types of stereocenters.